talk, which is running GPU jobs at scale with Slurm on Kubernetes. So maybe, Nico, this is answering also your question. Thank you, Edu.
Yes. So, yes, like, I mean, going to conferences this year is hard for me because, yes, NVIDIA acquired ScareMD, but we will do our best to have it as a first-class citizens. And as I'm saying, the message I'm trying to give is, no, Kubernetes is not going to kill Slurm. They will be friends forever, right? So, yeah, going to conferences this year has been hard for me because people look bad at me because of the whole acquisition. So Kubernetes doesn't cheap SPC scheduling, as I was saying during the QA, right? Kubernetes is not good at gang scheduling, it's not good at fair share, it's not good at topology-aware. Kubernetes is just not good for this. There are multiple projects trying to do this natively in Kubernetes, and there have been great processes like Volcano, Q. There is progress on that. But we have a Slurm, so instead of trying to build something from scratch, why don't we just make them friends, right? So Slurm and Kubernetes are converging. As you can see here in the timeline, Slinky is not something new. The community was asking for this for years, and in 24, ScareMD finally kind of like addressed the community by open sourcing Slinky, which they were working since 23. So this is a topic that has been taking years. And NVIDIA acquires ScareMD in December. And now, in my team, I'm very proud to say we are running GPU clusters, over 8,000 GPUs using Slurm on Kubernetes. So it is already running in production, and we are running huge training sets with Slurm on Kubernetes. So from the driver all the way to Slurm. So this is not something that is just like putting a Slurm on top of Kubernetes, right? To get where we are today, we, as NVIDIA, had to contribute to the entire stack, right? So we have people contributing from the NVIDIA driver, that is ours, but now we are open sourcing as much as we can from the NVIDIA driver, all the way to the jobs. So we had to contribute all the way to how Kubernetes sees jobs in order to play well with Slurm when Slurm is running side by side with Kubernetes. So the entire software stack has, like, we had to modify it in order to make this possible. So I want you to see that when we say Slurm on Kubernetes, is the entire software stack that we are working on to enable HPC on Kubernetes. So there are two things. ScareMD, when they open sourced it, Slinky, and this is a big confusion in the community. Slinky itself really means the GitHub organization that ScareMD used to open source two projects, right? So I still hear people saying Slinky as the technology itself, but that's not the case. Slinky is the name of the GitHub organization where ScareMD kind of like umbrella two technologies, a Slurm Bridge and a Slurm Operator. A Slurm Bridge is a way to run a Slurm as a secondary scheduler to Kubernetes. So Kubernetes has a plugin technology that is called the scheduling framework that allows you to change the scheduling decisions of Kubernetes across multiple checkpoints of the scheduling decisions of Kubernetes, right? So every time Kubernetes is making a scheduling decision, it exposes that information into a framework, and you can say like, oh, no, don't do that, do this. So you have that capability via the scheduling framework. So a Slurm Bridge use that to have a Slurm looking at Kubernetes, making decisions, and telling Kubernetes, oh, don't do that, do this. That is a Slurm Bridge. A Slurm Operator is what in the open people say a Slurm on Kubernetes. So a Slurm Operator, as I will be showing today, is running an entire Slurm, you can say containerized cluster on top of a Kubernetes cluster. So what is happening here is that the Slurm Operator blocks nodes, then uses a daemon set and deploys an entire virtual Slurm cluster. But I will show it. So a Slurm Bridge, it's a Slurm thinks Kubernetes or the kubelet runs. So this is kind of like the thinking process, or when Kubernetes is thinking to run something. You request a pod, so the pod is the unit that actually goes to the node when you're running. Then there are some admission webhooks. Then the bridge scheduler tells Kubernetes how to think, because Slurm is overlooking the entire cluster. And then Kubernetes receives that information, and it binds the pod to a node and run it, right? So this is basically the step-by-step on how Kubernetes communicates to, not to Slurm, but to the scheduler framework that it is about to make a scheduling decision, and Slurm helps Kubernetes with that. So Slurm thinks, Kubernetes runs. So it's basically co-scheduling HPC and Kubernetes, right? So this is a Slurm bridge. So when you deploy a Kubernetes pod, the Slurm bridge takes charge, but it also have the whole Slurm CTL, and you can also run Slurm jobs, right? So you can run Slurm jobs, and you can run Kubernetes jobs on a single cluster using a Slurm bridge. So a Slurm bridge is for those that still want that Kubernetes experience of running regular Kubernetes jobs and just letting Slurm take care of everything, right? Like, you can still deploy your workloads to Kubernetes without having to use special objects or special jobs. You just deploy things to Kubernetes, and your system admin is making sure that Slurm helps Kubernetes to properly allocate that pod. So the Slurm daemons become basically Kubernetes CRDs. So this is the Slurm operator. So a Slurm operator is a Slurm running as basically a daemon set on top of Kubernetes. And what happens here is that we create a virtual Slurm cluster inside a Kubernetes cluster, where you can even, you have a login set where you can, which hurts me, you can SSH into pods in Kubernetes and deploy jobs into a Slurm using regular Slurm CTL commands. SSHing into a Kubernetes cluster, SSHing into a pod is a total wrong thing to do, but it's what the community has been asking for. Like, if you ask me, I will have deprecated SSH a long, long time ago. Like, users should not be SSHing into Kubernetes clusters, but the community asked for this, and the Slurm operator basically gives people a login node where people can deploy regular Slurm jobs. And we have the node set, which basically turns one Kubernetes node into one Slurm node. And yeah, the controller is basically a big head, making sure that everything is healthy and everything is in sync. So this is a bigger picture. So the controller pod, again, is the head where we host the Slurm DB, the Slurm REST processes for those that kind of like understand Slurm more than just deploying Slurm jobs. And on the login pods, you can do sbash, you can do srun, you can do all of that stuff, SSHing into a pod. And the Kubernetes cluster, each Kubernetes node becomes a Slurm node with its Slurmd running. So it's basically a basic Slurm cluster, but it is running as pods on a Kubernetes cluster. And answer then to your question, why system admins and users like this? Is because you can scale this. And scaling up a Slurm cluster is really hard. Scaling up HPC is really hard. But when you give that to Kubernetes, that the controller pod makes sure to auto-scale your Slurm cluster. When you add or remove nodes from your Kubernetes cluster, the controller pod will simply get that from Kubernetes and will go and reconfigure your Slurm cluster. Then voila, your Slurm cluster is auto-scaling thanks to Kubernetes. So we have auto-scaling, self-healing, cloud bursting by default now, because Slurm is just a process inside Kubernetes. So this is why they are friends. Okay. So we reuse what Kubernetes already solved, like GPU management. We are, and it's a personal feeling, we are putting a lot of effort into making Kubernetes a first-class citizen into GPUs. And before NVIDIA acquired ScareMD, that was not the case for Slurm. So at some point, we were putting too much effort into making Kubernetes good to run in GPUs, but on Slurm, it was up to the community and to ScareMD to make Slurm good on running on GPUs. But now, everything that I showed in the first part of this session, that is the fine-grained control of GPUs, NVLink, interconnects, and now that we are growing to CPU and memory, all of that is going to be also part of your HPC cluster. So your Slurm running on Kubernetes will have that fine-grained control, that GPU not just GPU management, but system management, device management. Configuration and identity, you can do secret rotation, key rotation on top of your Slurm cluster. You can do volume reconfiguration. You can do everything that Kubernetes already has automated for your Slurm cluster without doing it with the tools that have been presented here since yesterday and today, using Werewolf and using all these old-school HPC tooling. Now you can just do them with Kubernetes native automated tools. You can automate your entire Slurm cluster. And as I was saying, observability and operability. Kubernetes is much better than any HPC resource on doing Grafana, Prometheus, dashboards, monitoring, self-healing. Kubernetes is just simply better on that than HPC tools. The scheduler has to know the fabric. So here we are facing one of the most interesting problems of Slurm and Kubernetes, and is having two heads trying to make a decision. Right? This is a meta-scheduling problem. So we need to let both Slurm and Kubernetes about everything that is happening on the entire system all the time. So one of the projects that we open sourced is Topograph, that is a daemon set that allows Kubernetes and Slurm to understand the topography of the system so we can do topology-aware scheduling. We also have open source projects that expose not just the system itself, but the internal NUMA topography of each node to Kubernetes. So we can now do topology-aware from the system, and then when we're running on a node, we can do NUMA-aware scheduling in Kubernetes. We then expose compute domains, as I showed also previously, which help you allocate a workload of a pod to consume multiple GPUs using NVLink. Right? So this was not possible before. And then we expose all of that to Slurm. So we do everything with Kubernetes native objects and expose that to Slurm, so it's just native to Slurm. So now you see why they, like we say, they are friends. So we are doing all the system management via Kubernetes. We are doing all the drivers management in Kubernetes, and then we just hand it over to Slurm. So Slurm has that fine-grained control over what is happening on the system. Two systems, one source of truth. So Kubernetes and Slurm, they think very differently. So that's why when I was showing here the controller pod, so this slide is speaking about the controller pod. The controller pod is in the middle. If you need to do some node draining or health checks, it needs to be on both sides. So if a node goes down, Kubernetes and Slurm need to know it right away. So the controller pod is making sure that if a node goes down, or if you are doing auto-scaling and adding nodes to the system, Kubernetes and Slurm need to know it at the same time. So Slurm, for example, doesn't think that you are resource constrained, but actually your Kubernetes cluster has nodes, extra nodes, because you auto-scale it. So having this in sync is the responsibility of the controller pod and the Slurm operator, where it is constantly making sure that Kubernetes and Slurm, the state of the system, is in sync. Production today. My team, we have a blog post about a run we did of 8,000 GPUs running Slurm on Kubernetes, and we will be presenting this at the Cloud Native Days Munich. So in 3 weeks from now, we will be talking about how we did it, and all the challenges of running 8,000 GPUs with Slurm and Kubernetes. We are running thousands of GPU worker nodes. I'm talking about the node, not the GPU itself. We're running thousands of these for training for all the AI companies. And you can get from 0 to running your Slurm on Kubernetes cluster under an hour. So it's a matter of minutes. If you have your Kubernetes cluster running, we have everything packaged as a Helm chart. And basically, in a matter of 10 to 15 minutes, you are ready and even Nickel certified to run your HPC processes on your Kubernetes cluster. Where are we? So the Slurm operator is on its 1.1 version. These are the roadmap if you want to take a screenshot of it, or it is totally open on the Slinky, github.com/Slinky organization. The roadmap is how do we do graceful cluster upgrades? So this is still, it's very clunky to do. Rollbacks, outage for workflows is still very clunky because the way Slurm and Kubernetes think about an unhealthy system is a bit different. So we need to make them think in a kind of like similar way when a node is going unhealthy or when a process, when a workflow is going unhealthy. We need to make this better. We are working really hard. I didn't put it here, but on the CPU and memory as a special resource, that is also on the roadmap, but on the long roadmap, not on the near-term roadmap. Constraints that we know we have, the single node jobs is still better with Kubernetes than using Slurm on Kubernetes. The operator is good for multi-node scheduling, so for running MPI processes on Kubernetes. But if you are going to do something like a Monte Carlo run or something like that, you can still use Q or Volcano or any of the other Kubernetes tools for this. So Slurm on Kubernetes is really when you want to launch a big distributed workload in your system. So again, the message, keep Slurm, get Kubernetes. So it's not one will beat the other, as has been the conversation. Kubernetes is basically the operating system for distributed systems. Now we are installing Slurm on this operating system. That is all we are doing. One is not replacing the other. Kubernetes is just the operating system for distributed systems. You can Helm install, define it, and you can start running under an hour. And again, questions?
Thank you very much. We have plenty of time for questions. You can have questions on this one or on the previous one. You can just hassle him
or
with questions.
On the lunch break.
Yeah, but we need to give some time to them to be ready. It's in 20 minutes.
Yeah, since it was 2 talks, I was talking too fast because I was not keeping track of time.
Thank you, Edo, for the presentation. So regarding the login node comment that you made, right, the login set, what would be your proposal then to provide login functionality for HPC or traditional HPC users that expect to be able to SSH and run SBatch and SRun, right?
That way. You are saying the word traditional. That is the traditional way.
So we have dedicated nodes, and can we have dedicated nodes that connect to the Slurm operator?
Yeah, you can. Yeah, that's the whole point of the Slurm operator. So people can SSH into a place and use SRun, SBash to run their workloads. But the Kubernetes way, so like the conflict I have is that I already love the Kubernetes way. And the Kubernetes way is like everything is an API. So like users should not SSH. Everything should be ready, and users should just be doing API calls without SSH. So that is less risky than SSH. You have APIs, you have API keys. So users have an API key. They use the Kubernetes API. They tell Kubernetes to do something.
Okay, so if you want to run a command, you're suggesting to use to generate a YAML file and.
Why do you want to run
I don't know.
command? There are tools for that in Kubernetes for debugging entire nodes and entire systems. like going into a node and still like doing CAT, NLS, and also knowing like mproc and all of that is being exposed. Like for NVIDIA, we have DCGM, and we have many processes that are exposing information in real time, so you don't have to go in the node to debug. And all of that gets exposed as Kubernetes logs.
Performance analysis and application tuning usually requires instrumentation.
Again, a lot of this is roadmap, and my dream, and that's why I work in this team, and that's why I lose sleep contributing to all of these projects, is that my dream is someday to remove SSH. So that's what keeps me up at night.
Yeah, I think the main problem is that scientists don't like learning new things, or technology-related new things. Let's say they have
I
their
get that,
daily
but
job. Right?
my goal is that if it gets so good, researchers are going to want to use it.
Yeah,
but
it needs to be simple, right? And I agree with Jordi. If you try to create a job definition in Kubernetes, right, it's many times more complicated for a scientist to do it than just to run hostname. Right?
It sounds like that, but have you seen those SBash files that are like pages long? Because
I know.
specialized HPC, and when it comes with these specialized GPUs that have NVLink and MPS and MIG, is not just run this Fortran in that GPU. It's like I have this ultra specialized C++ code that requires the GPUs to be configured like this, and that NVLink is like this. So like all of that is very fine-grained control, we are exposing that to Kubernetes as APIs. So you can simply use APIs, configure Kubernetes, we reconfigure the cluster in seconds, you run your workload, and then it's back to the defaults for the next workload. Versus in Slurm, in HPC, is like a lot of, and even next week in ISC, is like, oh, these are my 20 pages of Werewolf to reconfigure the cluster for climate research. Or these are, you see the point?
Yeah. So I have a second question, and it's, we have many different sizes of clusters represented in this room, right? Do you see in the future, and this is more an opinion question, do you see in the future Kubernetes becoming the default operating system for all kind of HPC-related environments?
Yeah, sadly, and I'm on that side of the sadly, there is a line that is follow the money. If you compare the amount of research and R&D, research and development on cloud providers like Google, Amazon, Microsoft, NVIDIA, versus the R&D budget of the entire HPC community, the HPC community is a rounding error of the budgets of the cloud computing, right? The amount of engineers, for example, a month ago, it was the Cloud Native Con in Amsterdam. It's already getting to 20,000 engineers, all focused on making Kubernetes better every day. If I go to supercomputing in Hamburg, it's 10,000, and half of the conference is sales representatives. So yeah, sadly, that's a way. Sadly, is follow the money. Kubernetes has become already the operating system for how Google is run, for how Microsoft is run, for how Amazon. Then everyone will follow, and mostly because of how vendors and how hardware companies see that, right? Like if I'm NVIDIA or any hardware vendor, I focus on the main customers, right? Not on the rounding error. So it's more like a follow the trends conversation than a technological conversation. But it also works, right? I don't think there is an HPC side that has GPUs as Google has, right? And Google can do multi-node GPU training on Kubernetes already. And for them, like when I have conversations with them, having a GPU not being used for a second is billions of dollars. So they care about performance. It's not like we have so much money we can waste it. No, no, no. When NVIDIA and Google sit to work on Kubernetes, it's like every second of a GPU not being used, we are wasting money. So we are very, very, very worried about performance.
Jumping to this topic of performance, do you have an estimation if there is some kind of overhead running classical HPC applications, MPI and so on, with adding this layer, this Kubernetes layer in?
The smaller, the bigger the performance degradation. It's what I would say on a hardware level. If you are going to run a benchmark on a 100 node cluster, you will see kind of like a 98% performance in Kubernetes versus a bare metal Slurm. But when we start talking about this 8,000 or 10,000 or Google scale that is hundreds of thousands of GPUs, it becomes a 0.0000001% performance degradation, which from the point of view of system admins and management, is a trade-off that we are really happy to do, right? Because the 1% performance that we are losing against a Slurm on bare metal is the headache of running a Slurm on bare metal, right?
There's only one Google, the rest we are not Google, so.
Yeah, no, but I say like, when people ask about performance degradation, it's like, I will trade that 1% any day for not having to do all the reconfiguration and losing the automation that comes with Kubernetes. So it's the trade-off. Right? Like I know that a very well fine-tuned cluster can do, but it's like a do not touch because it's working, then who can use it? But if you, yeah, but that's the thing, like, for HPC size, like for example, the Barcelona Supercomputing Center, you spend weeks fine-tuning it for climate change. But then the bioinformatics cannot use it because it's tuned for climate change. Yeah, you are leaving your researchers away. Versus in Kubernetes, we are able to do this automatically and trading off a % of performance. And you can have all your researchers happy at the same time. Mm-hmm.
So, what is the management overhead of running Kubernetes, right? In traditional HPC, we're used on how to deploy a cluster. We know how to manage it. Kubernetes is a whole beast on itself to deploy and manage and make sure that everything is working. Is it worth it?
Yes. Yes, because in Kubernetes, everything as I'm showing you, everything to the hardware becomes an API. With a Slurm or with other like HPC on bare metal systems, there are things that you need to, as Jordi, like you need to go to the node and SSH and fix it, right? What we are working on, again, is not today, it's a roadmap, is that using APIs, you will be able to like do firmware configuration on your GPUs, just using APIs, right? So right now, even on a Slurm cluster, if you want to do MIG reconfiguration of the cluster, you need to have maybe like Ansible scripts or things like that to do MIG reconfigurations. In Kubernetes, now it is an API call. And that is not running a job or not. We are talking about system admin work. So one API call and you change all your MIG configuration in your cluster. So it takes time to learn. It's a lot of APIs. Everything in Kubernetes is an object. Yeah, it's a new ecosystem. But like where we are going is everything is an API to the firmware level.
But for this versatility, I can use SSI with OpenChami that Jordi showed yesterday, or
Sure.
the multiple control plane that Massimo showed again yesterday. And
Yeah, but can you use those
multi-tenancy.
tools to automatically auto-scale in burst? Can you use those tools to, in one API call, install Grafana and Prometheus? Can you use those tools to, in one API call, get all the logs from the kernel?
I like your answer.
Yeah, again, I'm very passionate about HPC, but also I do love Kubernetes, and we want to make Kubernetes as the operating system and make it better for HPC. So, for example, an example that I really, really like is everyone here, I guess, knows CERN, the supercomputing center and scientific center. They are running Kubernetes, and they run Kubernetes at scale, and they love it. So it takes time. They invested in Kubernetes for years, but now they love it. So.
We have a question from online attendees. Following the previous cloud-native investment in Kubernetes question, do you see that eventually Kubernetes will have all the Slurm features and we will only need Kubernetes but not Slurm Slinky? Is this considered in the Kubernetes long-term roadmap?
It is a Kubernetes long-term problem. Our goal as owners of Slurm now, NVIDIA, is to make Slurm a first-class citizen and not have to rewrite things, right? So we are donating as much things as we can to the Kubernetes ecosystem. We have been donating, in the past year, we donated like 2 or 3 projects. And even now, the Slurm employees working at NVIDIA are contributing to Kubernetes. So that's the mix we want to do. So it's not Kubernetes replacing Slurm, but it's like we want to have these brilliant minds that have been working for decades in Slurm to take a look at Kubernetes and help us do the merge, right? That's why the project is called Slurm Bridge. We are just trying to bridge the 2 communities, but I don't see a replacement. I just see Slurm becoming so Kubernetes is as a whole system. That's why sometimes you see it as KAS. So it's basically 8 core components. So who knows, like at some point it would be K9S, right? That is, Slurm is just one of those components, but it's not a replacement.
Thank you. Any other question?
I was about to make a comment. I was looking for the data to comment here. So according to SIG HPC, a survey on the top 500 sites, back in 2024,
there was
making
like 1 or 2 Kubernetes clusters in.
No. So 56% .4 was running as Slurm. The second workload manager, who can guess what it was? It was Kubernetes. And it was with 10%. It was the second most popular in the top 500. If we run today this survey again,
Yeah, who knows?
it will
Next
show
week.
that NVIDIA now owns more than quite a large share of things, right? So yeah.
Well, NVIDIA owns Slurm, so it owns 50% of that share.
Yes,
Already.
but also Kai and also other few bits and pieces. Yes. Kai
Okay.
and AI.
Thank you very much, Eduardo, for your 2 talks.
Thanks so much.